Welcome. In this video, we are going to learn about detecting a bright spot using OpenCV library. We are going to learn about object detection and tracking. We will detect object and we will learn how to track objects using color spaces. So first, let's run this Python script and let's see what the output result is, and later on we will see the code. Let's open the terminal. You can see that I have my image, that is retina.png, to spot out. Now I'll run my command as python space brightarea.py and pass the argument, that is image retina.png, and also pass the radius of an image. I know it's pretty much weird, but anyhow, I have written the code in that way. So we'll hit enter. You can see that it's spotting little new image here. Now you see another image generated with robust image for improved spotting. So in this way you can do it for all images you want to detect the bright spots. So one is a new and other is a robust. So now let's see the code behind this one. As you have already guessed, the procedure is pretty much simple, that is converting it into grayscale, and then we'll perform a naive attempt to find XY coordinate of the area of the image with largest intensity value, and then we will apply a Gaussian blur to image and then find the brightest region. So let's see it. First we'll type import numpy as np. We'll import the numpy module. It is an open source extension module for Python, which we have already discussed, so I'll not say it again. The new one I'm introducing here is import argparse. The argparse module, you can say argparse, makes it easy to write user-friendly command line interface. It's not that important to include it, but anyhow, I have included it. And the next one, import cv2. cv2 is a very popular library for computer vision on which our whole object detection section is based on. So now let's construct the argument parse and parse the arguments for image file and radius of an image. That is ep equals to argparse.argument parser, and then parse the argument for image file, that is ep.add argument -i image help equals to part to the image file, that is parse argument for image file, and finally the radius of an image which will take the input, that is ep.add argument -r radius type equals to int help equals to radius of Gaussian blur must be out, args is equal to variable ep.parse arguments. Now we have constructed the argument parse and parse the argument for image file and radius of an image. In short, in simple language, we have took the input of image and we took the input of radius. Now next, we'll load the image and convert it to grayscale. That is image equals to cv2.imread arguments image over ig equals to image.copy. We'll make it grayscale. Gray equals to cv2 cvt color image cv2.color pgr, that is color 1 to gray. So in this snippet we have loaded the image and converted it to grayscale, and now we will perform a new attempt to find XY coordinates of an area of an image with largest intensity value. For that, minimum value, minimum location, maximum location equals to cv2.minimum location in bracket gray, cv2.circle image max location 5 to 555002. So here we have just performed a new attempt to find the XY coordinate of the area of the image with the largest intensity value. Now let's display the result of new attempt of an output image, that is cv2.imshow new, image. Now we'll apply a Gaussian blur to the image, then find the brightest region. Gray equals to cv2 Gaussian blur gray arguments radius.arcs radius 0 minimum value, minimum location, maximum location, cv2.minimum maximum location gray, image equals to or ig copy, cv2.circle image maximum location, arguments radius 255 0, 0, 2. So this one will apply a Gaussian blur to the image and then find the brightest region. Now we'll display the result of our newly improved method for spotting the brightest spot. It is cv2.mp4 robust, image, so that the image should weight will write cv2.weight key 0. Now the program is done. Let's see the output again, which you've already seen, but anyhow we'll see it again. In command we'll type python space bright area.py and pass the argument as image name retina.png and also pass the radius of an image. Now run the command. You can see that it's spotting the little new image there, the small circle. Now see another image generating with robust image for improved spotting. So like this, you can do it for all images you want to detect the spots. So that's it in this video on detecting a bright spot using OpenCV. Thank you for watching this video.